Hey there, coders. Welcome back to another exciting episode in our Rust programming series. Today, we are diving into reference and borrowing in Rust. This concept is at the heart of Rust's memory safety, allowing you to write robust, bug free code. We will explore what references are, how borrowing works, immutable versus mutable reference, Rust's rule for preventing data races, and dangling references. First, what are references in Rust? In Rust, a reference lets you access a variable's data without taking ownership of it. This is crucial because ownership rules in Rust are strict. Once ownership is transferred, the original variable becomes invalid. Let's see in CodeEditor how it works. First, create a function called calculate length, which takes string and return back usize stop length. Then let's create a variable named as s1. First, in this function signature specifies s this as string, meaning it accepts a reference to a string. This tells Rust this tells Rust that the function won't take ownership of the data, but it will borrow it temporarily. Now, in this line of code, this creates a string object with the value hello. String is heap allocated growable type in Rust. Here s1 is the owner of string hello. Now create one more variable named as len and call the function calculate length s1. Sorry, int len, not int len. Select len here and s1. Here, instead of transferring ownership of s1 to the function calculate length, we borrow it using and s1. The AND operator creates a reference to the value of s1. Borrowing means we can pass the string to the function without losing ownership of s1. In the next line, print ln s1 with len. Here, after the function call, s1 is still valid because we only borrowed it. Ownership of s1 never changed. Let's see in the output cargo run. The value of hello is 5. Here see s1 is still valid. So there it is. Now in the next part, move to mutable references. By default, reference in the Rust are immutable. This means you cannot change the borrowed data, but Rust allows you to borrow data mutably, enabling modification. Let's see how. First create, first remove all this thing and create a function fn change some string which takes mute string. After that, some string dot push. It's okay. And mute string. What this error? Sorry. Some string. Now in the main function, let's create one mutable variable named as hello and call that change function. Some string, not some string, and mute s. Here in this function fn change, this function signature includes and mute string here. indicating it accepts some mutable references. Rust allows the function to modify the data through this mutable reference. Here we declare a s as mutable using mute keyword. This allows us to modify s later in the program. Here we call the change function passing a mutable reference. Passing a mutable reference using and mute. This means the change function can modify the contents of s. Now print the final value. Hello world. In the print function, after the function call, the changes are reflected in s. Ownership of s was never transferred. We just modified it via the mutable reference. Now, so far so good, but Rust enforces strict rule to prevent data races and ensure safety when using mutable reference. Let's look at rule next. That is restriction on reference. Only one mutable reference. Rust does not allow multiple mutable reference to the same data simultaneously. This prevents data races. Let's see how. Remove everything. One more time, let's create mutable string s and create one variable. Let r1, let's say r1 and mute s. Sorry. Let's create one more variable. Let r2 and mute s and print it. Print back both. Here, error comes. Error is cannot borrow s as mutable more than once. R1 and R2 both try to borrow s mutably. If two mutable reference existed, one could modify s while the other is reading it, causing unpredictable behavior. So Rust prevent this at compile time. So let's comment out this and now see. Remove this and this. Now, how to resolve this conflict? We resolve this conflict by using one scope, creating one scope. Let's see how. Remove this, also this, and create one scope. Here, let's create one variable r1. By enclosing r1 in its own scope, it get dropped before r2 is created. Let's create r2 out of the scope. Create r2 out of the scope and use it. Print ln r2. Here we have resolved this conflict using the scope method, using scope. Now rule 2, no mutable and immutable reference together. Rust does not allow a mutable reference to coexist with immutable reference. Let's see what I'm talking about. Let r1, let's create one variable named as r1 and immutable here. Let's create one more variable. Let r2, sorry, caps lock. No problem here. Now let's create r3. Here problem starts. Immutable reference r1 and r2 conflicts with the mutable reference r3. Rust ensures that data being read through immutable references is not modified simultaneously. Here we can't borrow s as mutable. Let's print out and see the error. Mutable borrow occurs here. Now how to resolve this conflict? We resolve this conflict by using r1 and r2. here. Here R1, R2, I have to remove R1 and R2 and this part also, and now it's done. Hello. Here no conflict, remove this. Here no conflict as R1 and R2 are no longer used. Last use of R1 and R2 is here. So this way you can resolve the conflict of no mutable and immutable reference together. Now in the fourth part, we see the dangling references. Rust ensure reference are always valid by preventing dangling reference. Means remove this, and if we create a function, let's create a function fn, name it dangle. Here s is dropped. Here s is dropped when the function ends, leaving a dangling reference. Rust prevent this at compile time. S is created here, returning a reference to s, and s is dropped here. So s is dropped when the function ends, leaving a dangling reference. See the error in the compiler? Returns a reference to the data on by a fix on by the current function. So how to resolve this? Resolve, let's make it no dangle function and remove the ownership reference, sorry, remove the ownership. Now error goes and let s equals no dangle. Let's call that function and see the output here. Hello. So that's all for today. We covered reference and borrowing, immutable and mutable references, Rust's rule for safety, avoiding dangling references, and that's all for today. If you I will see you next one. Let's keep building with Rust. Thank you.